When you're considering performance in computer terms, there are 4 key system resources: memory or RAM, the processor or CPU, the disk, and I'm thinking here of the physical disk rather than a logical disk or partitions, and then the network. If any of these items or any of these resources is under strain, then that can affect the overall performance of a computer. If you are able to measure the responsiveness of these key resources and see whether they're under load based on numerical values, then you can take action such as, I don't know, replace a disk subsystem with one which is faster, or distribute the application load onto other computers, or add memory to the computer, or whatever it might be. But how can you determine whether these resources are under strain? Well, we've already seen things like Task Manager, which can give us a snapshot of system performance. But really, we need to measure over a typical period of time. The Performance Monitor tool allows us to do that. The Performance Monitor node in the Performance Monitor tool provides us with a graphical real-time index of what's going on. You can see here we've got a colourful graph of a number of different objects. Down the bottom we've got counters and instances and so on. I'll discuss those in a moment. You can also see in the navigation bar data collector sets and reports, and I'll be talking about those also. So the Performance Monitor is the tool to go to if you want to establish whether or not a computer is responding appropriately and whether or not a particular system resource is under strain and needs investigating further. There are a number of common counters. To determine memory responsiveness, take a look at % committed bytes in use. That gives you an indication of how much memory is currently in use, how much of the physical memory. So clearly 90% of committed bytes in use means that you're looking at knocking on the upper limit, 100%. Memory pages per sec is my preferred counter. It tells me how much paging is going on. As you may well know with Windows 10, when you haven't got sufficient physical memory, then paging takes place. So overcommits in memory are written to disk being much slower than physical memory. So measuring how much paging is going on through the pages per sec counter is useful. So that's the memory object pages per sec counter. You can also examine the paging file itself and see how much it's being used in percentage terms. This is useful to determine how much extra memory you might need to add. If you've got a paging file of, say, 4 gigabytes, and you're using 50% of it, then that indicates you probably might benefit by adding 2 gig, i.e. 50% of the 4 gig paging file, in physical memory terms. For CPU, examine the processor object and look at the processor time counter. It's a percentage. It's how busy as a percentage of time is the processor. If it's busy 50% of the time, then it's 50% of the time it's doing nothing, on average. Once that gets up to quite a high value, you need to investigate further. But it's important to look at also the system object processor queue length. That's how many things are waiting to be processed by the processor. The longer the queue, the bigger the indication that the processor hasn't got enough capacity to deal with what it's being asked to deal with. Physical disk, % disk time gives us a measurement of time, how busy are the physical disks. So the disk counter % disk time 50% might indicate that 50% of the time it's busy, 50% of the time it's idle, so no problem. But the higher that percentage climbs, the more significant the disk will become in terms of slowing down overall system performance. Likewise, physical disk average disk queue length indicates how many items are waiting to be serviced by the physical disk. The network's a little bit more tricky. Sometimes you can take a look at some of the network counters and it might be indicative of a network problem, but that may be a network problem elsewhere rather than in the local network interface itself. So the reason there are things sitting in the network interface object output queue length counter are because there's a router configuration issue which is slowing things down. So when do you need to take action? Well, these are only rough guidelines, but when the memory object % committed bytes in use exceeds 80%, think about adding some memory. When the memory pages per sec counter is increasing over time, it reckons or it suggests that you have insufficient physical memory, so add some physical memory. How much physical memory? Examine the paging file % usage value. The paging file is a hidden file in the root of drive C, usually. Examine that. how big is it on the disk, multiply that by the percentage usage figure, and that says how much memory to add. Physical disk average disk queue length. If the value exceeds twice the number of physical disks, there might be a disk bottleneck. Most computers have a single physical disk, so if the average queue length is greater than 2, that may indicate a problem, especially if you combine that with a value for percent disk time exceeding 85%. So those two together can indicate a potential problem with the disk. What can you do? Well, if you're using an old technology disk with physical components that move, consider swapping for an SSD. On a workstation, that's probably the most significant thing you can do. In processor or CPU terms, the percent processor time value exceeding 85% indicates the processor is overloaded. There will be times when it's trying to exceed 100 and can't, and so things are being stuck into a queue. Examine the system processor queue length, and again, if this value is more than twice the number of processors, most computers have a single processor, then you're looking at a processor being overloaded. So the two figures together indicate the need to take action. And as I said, the network interface output queue length is the indicator for problems on the network. It's difficult to say what action you need to take. I would investigate further and see if the problem is elsewhere before you start swapping out network cards. To collect this information, I'd recommend using data collector sets. You can configure user-defined based on a template or based on manual configuration. We'll look at this in the demonstration. And as you can see on the right-hand side, I've chosen to create a performance-defined data collector set, and I've added the appropriate objects, performance counters, memory, pages per sec, processor percent processor time, the ones we've just discussed. I can also use a system diagnostics data collector set to examine what's going on in the computer in terms of reliability rather than performance. And I can use built-in system performance data collector sets. So data collector sets gathers the performance statistics to a log file over a measured period of time. You can use this to create a baseline, and then you can examine the current performance by creating a new data collector set for the same counters and compare. Reports are useful for taking a look at what you've just collected. Whenever you create a data collector set, an equivalent report is automatically created based on the information that you gathered. You can view the result of that gathered information from your data collector set by using a report as a chart or a graph, or as you can see here, as a textual report. You can then use the information listed here to try to interpret what's going on in performance terms. The concept of a baseline. A baseline is an ability for you to determine a typical workload for a computer. So perhaps you deploy a fresh workstation, you install all the apps on it, and you generate an amount of workload that you think is representative of what will happen on a workstation, and you measure that using Performance Monitor, and that establishes the baseline. Thereafter, if a user is experiencing a problem, you can record the same statistics in the same data collector set and see if anything's changed. So it's a process of comparing to the baseline. It enables you to accurately monitor resources over time and identify how resource use has changed. You can also use it to test a reconfiguration and obviously to help diagnose problems. So let's take a look at Performance Monitor. We'll create a baseline and then we'll gather and interpret performance data and make a comparison. Okay, so having a look at Performance Monitor. You can see there are a number of tools. The Performance Monitor tool itself, this defaults to showing you a live graph or a live chart of processor time. It's not particularly useful, that, but you can customize that using the control tools up the top here. Data collector sets allow you to gather statistics over a period of time, and then reports allow you to view and analyze the data collector sets. Let's take a look at using Performance Monitor. So we'll get rid of this counter. We will start a new one. Now it's worth bearing in mind, if you use Performance Monitor to gather live data, you're just getting a snapshot of the computer system, and that's not particularly useful for analysis purposes. You'll scroll through and you will select the appropriate object the typical objects will be things like, let's go to memory. And then beneath a given object, you have the ability to select particular counters. So when you're looking at live data, it makes sense to be fairly specific, because otherwise it's quite confusing looking at all that's going on. So choose a particular value, pages per second, click add to put it over onto the chart, and then click OK. You can now see pages per second is indicated here. And you then add additional information to the chart. But as I said, that's of fairly limited use. It's more useful really to use a data collector set. Data collector sets will measure performance or any other statistics that you want over a particular period of time. For baseline, you need to determine what's an appropriate period. No point measuring the activity when people aren't on the network, likewise when they're very busy signing in or signing out. So look for a representative period, maybe 10 a.m. till noon and 2 p.m. until 4 p.m, something like that, whatever works in your organization. You can create a user-defined data collector set, either from a template or manually. I'm going to create a manual one. And then I can go for a counter alert, in this case a performance counter alert, or by using create data logs based on performance counters. In this case, I'm going to go for performance counters. An alert would be a situation where you are monitoring the system to see if, for example, the usage of the processor exceeded 85% for more than 10 seconds, and then it would do something based on that. So it would tell you if a user is experiencing problems, intermittent problems, you could use that technique to be alerted that that problem looks about ready to manifest itself. So I'm just going to go for a create data log option and choose performance counters. Then I need to specify what the performance counters are, and also an interval, sample interval. The shorter you make the interval, so if I set it to 1 second, for example, the more data you'll collect, but the more load you impose on the system purely through the collection process. It makes sense actually to use one computer to monitor another. So that allows you to gather more statistics without actually generating an excessive load on the computer that you're monitoring and thereby invalidating the data that you're collecting. I'm actually going to monitor my own computer, so I accept that that's a not valid way of performing performance monitoring. And I'm also going to set the sample interval to a very low value, very short value, simply because I want to collect a lot of data in a short amount of time, because it's a demonstration. But typically you might want to gather every 15 seconds, and you'd certainly want to gather remotely. I'm now going to specify which particular counters I want. So I need to select the appropriate objects. Let's start at the top here and scroll down, and there may be something specific you're looking for, something to do with branch cache or browser behavior or whatever, or it may be more generic. So for performance purposes, the four key areas are the processor. Let's find that. And now you can either collect all the available data about the processor, or you can be specific and look for the percent processor time value. And down here, if there are several processors, you can select it for a particular processor or for all processors. So I'm going to select it for all processors, and I add that over here. Processor time is a measurement of how busy the processor is against time. The other significant counter for processor is actually not part of the processor object itself. It's part of the system object. There we are. And if I find processor queue length, then that will give me an indication of how many tasks are waiting to be processed by the processor. The next thing to look at would be physical disk. If I scroll up here, find that. There we go, physical disk, as opposed to logical disk. So we want to know what's actually happening on disks. Now this computer has a lot of disks, so I'll just select them all rather than focus on a specific. But once you've got an idea where your problem might lie and you suspect it's disk related, you can then drill down and look at specific disks. So there are two counters. We want to have a look at the average disk queue length. Again, that's how many items are waiting to be serviced by the I/O manager. So obviously the longer the queue, the more load there appears to be on the disk subsystem. And then percent disk usage. Oops, I'm way past that for some reason. Yes, there we go. So that's the percent disk time value. And again, I'll collect that for all. So those two things together, the percent disk time and the average disk queue length, tell me how busy the disk subsystem is, and the processor time and the system processor queue length tell me how busy the processors are. The other thing I need to know is about memory. So if I scroll down and find memory object, number of different ways of looking at this. One possible way is to look at the number of pages per second. The more pages per second that there are, the more the computer is using the paging file. It uses the paging file when it doesn't have enough physical memory. So an indication of excessive paging gives us a good indication of the fact that the computer's memory might be an issue. So pages per second is worth counting. You can also then take a look at the available bytes and the committed bytes and so on here. It gives us an indication, maybe more accurate, of what's happening. Available megabytes. That can be misleading because the available megabytes will increase if you page. So for me, the significant count is probably memory pages per second. Now, most things take place on a network, so the other thing you need to consider is the network itself. So have a look at the network interface, and you can see what the bandwidth is. Bear in mind that a bandwidth figure of 20% on a contention network like Ethernet may still indicate a problem. It's seemingly you have 80% capacity, but that's just not how Ethernet works. So that may be an issue. It's worth knowing that. It's not picking up the network for some reason. Oh, that's better. So we'll say, show me that. Or I can have a look at the output queue length. That's the number of things waiting to get onto the network. That might be useful. And then when I'm happy with that, I can click OK. Once you've got your data collector set up with all of the properties you want to gather, click Next. Specify where you want to save the data. It defaults to the currently signed in user. And then we can open the properties for the data collector set after saving it, so we can just view them, and we can start the data collector set now if you want to start gathering statistics. I just want to have a look at them to make sure that I've set everything up as I wanted. So click Finish, and as you can see, it opens it up here. It tells me what it's going to do. I don't have a schedule here, so this is going to be manually configured, but I could create a schedule where it will start and stop the data collector set. I can also set a stop condition that says once it's been running for a period of time, or once it reaches certain limits, then it will stop. I can also configure a task to run once the data collector set stops. So it might be that it launches a script that tells me that that data collector has stopped, or that sends me the data that was collected, whatever it is. So I'm ready now to start the collection. If I click on the baseline data collector set, you can see that there's some data here, data collector 0, 1. That doesn't contain anything yet. If I right click and say Start, it will start gathering statistics for me. So you gather that for a measured and appropriate period of time, and then you've got your baseline. Periodically thereafter, you need to collect the same information, and you compare what you saw before with what you're seeing now, and that might indicate that there's a problem. So you look at the report and you see that memory usage has changed, or you see that disk usage has changed, or that the queue length is higher on the system object, and you think, okay, so maybe I need to add some processor capacity to this computer or offload some of its workload. So let's do some work, see if we can generate some information. Open up a worksheet here. It's not exactly going to wear it out, I don't think. Let's open up some other applications. Don't have a camera, so that's probably a silly app to load up. Let's open up Help. Let's open up Music. And let's open up OneNote. And so it's doing some work, and maybe that's a representative a number of tasks. So let's go back to Performance Monitor now, and let's stop the collection. Now I can take a look at what's going on with that by looking in Reports, or I can take a look in the Performance Monitor tool. Under Reports, you can see user-defined baseline, and you can actually see the collector that's been generated. So in other words, it's automatic here. As soon as I create a data collector set, it creates a corresponding report once data has been collected. And I can now click on that report, and you can see some activity going on over here. it's a bit confusing. You can see a lot of stuff up and down in the graph. So sometimes it's easier to take a look at a report itself. And we can see that the pages per second were 524. That's quite a lot of paging. So I would suggest that maybe if we added physical memory to this computer and ran the same tests again, you'd see that being reduced. The network interface is not reporting anything because we weren't doing anything on the network. So hence the output queue length is 0 and the current bandwidth was fully available. Disk time is quite low and the queue length is quite low. So it wasn't really doing anything on the disk that was very taxing. Processor, 25% capacity, that's again nothing to worry about, and the queue length was quite short as well. So this indicates that this computer is working within its capabilities. There's nothing to worry about particularly. So I would now run the exact same tests again over a typical period of time, and then perhaps monthly, once a month, or a couple of days once a month, and then I could compare against what was collected here. So you can view this information in a number of different ways over a period of time. You can even look at it in a line graph, which you saw already, or a histogram bar. That may be useful for certain of these counters. And then you can export this information to a spreadsheet, and you can then produce that as part of a report for your management team. So Performance Monitor is a very useful tool. The actual Performance Monitor node itself allows you to gather live statistics. That's of limited practical use. Data collector sets allow you to gather information over a period of time, and reports allow you to view that information in a variety of different forms. In the demonstration, you saw how to create a baseline for performance purposes and to gather and interpret performance data.